Hi everyone, Mr. D'Souza here. We're going to go over quiz number 1. Please use the timestamps below so that you don't have to hear my voice for every single question, and you can just look at the questions that you need extra help in. So let's get to it. This first question said choose 3 out of the 4 problems. You did not have to do all 4, but I'm going to go through all 4. The square root of 10 is irrational. Why is it irrational? Because it's a non-perfect square. Letter B, 2.9823 has a pattern. It's rational because decimals with pattern are rational. Sorry for the handwriting. I gotta get better at that. Okay, next one. It's a fraction. Well, since it's a fraction, if it's rational, that means that the numerator and denominator must be integers, which means a positive or negative whole number. Well, 2 is definitely rational. 2 is definitely an integer. But the square root of 5 minus 3 is irrational. So since the numerator is irrational, then we can say that because it's an irrational divided by a rational, it must be irrational. Alright, next. I've never used this color. So this one looks more challenging, but it's actually not that bad. So this is also a fraction. The bottom is definitely rational because it's a terminating decimal. The square root of 25 is 5. That's rational. And 36.2 is also rational because it is a terminating decimal. So when you add 2 rational numbers, we've talked about in the last video, that's also rational. And when you divide 2 rational numbers, it's also rational. So because numerator, and denominator are rational. Are integers. No, it doesn't even matter because they're both rational. I should have kept that there. Are rational. Okay? And we know a rational divided by a rational is rational. Okay, question 2. Mr. Stipp asked his class, is the difference of 30 and the square root of 12 rational or irrational? Mr. Stipp answered that the difference would be irrational. So that's really saying, let me do a different color. 30 minus the square root of 12. We want to know if that's rational or irrational. Well, it says state whether Mr. Stipp is correct or incorrect. Justify your reasoning. Well, this is rational. This is irrational. A rational minus an irrational, in this case, is going to be irrational. So, to answer the question, Mr. Stipp is correct because 30 is rational and the square root of 12 is irrational. So a rational plus an irrational is irrational. Boom. End with a smiley face because we're happy, we got it right, we're moving on. The sum of 3 times the square root of 3 and 4 times the square root of 3. Okay? Sum means add. So 3 square root of 3 plus 4 times the square root of 3. We want to know if it's rational or irrational. Now there's a couple ways to do this. The first way we can do this is, well, 3 is rational. The square root of 3 is irrational. When you multiply them together, you get an irrational number. 4 is rational, and 3 is irrational. When you multiply those together, you also get an irrational number. Therefore, An irrational plus an irrational. Well, that's going to be irrational. Another way you could have done this is, well, 3 times the square root of 3 plus 4 times the square root of 3. If you remember any of your radical tricks, because these are the same radical, it's like saying I have 3 apples plus 4 apples. How many apples do I have altogether? 7 apples, but my apples are the square root of 3. So the same thing here. Well, 7 is rational, and the square root of 3 is irrational. And we know a rational multiplied by an irrational, there you go, is irrational. Boom. Moving on. So remember, you can always pause, rewind, fast forward these videos. Check the timestamps down below. There's no need to watch a question that you feel like or that you know is completely correct. Okay, circle the best response and explain. A lot of you didn't get this question. A lot of you didn't get full points on this question because you did not explain. A part of Jennifer's work is to solve the equation below. So, started off with this, then got here. If you notice, check out what's different. Just the left-hand side. She distributed. 2 times 6 is 12, so 12x squared. 2 times negative 3, negative 6. So it's not this, not this, not this. This is the only one that has the word distributive in it. So it must be this one. Explain why. On the left-hand side, of the equation, Jen, I'm going to call her Jen now, that's her nickname. Jen multiplied 2 by what was in the parentheses. That's the distributive property. Distribute property. And all in all, the only thing that we're missing or that we haven't really talked about was subtraction. That's because the operation is subtraction. Moving on. Okay, solving equations. This is such an important skill that you need for this class. Okay, so remember, don't call me impossible. Distribute, combine like terms, move the variable to one side, inverse operations. That's the order in which you want to do things. So let's use that as a reference. Is there anything here? So remember, our goal is to get x by itself. Is there anything here that I can distribute? Absolutely, there's 2. So 2 times x is 2x. 2 times negative 3 is negative 6 equals 12. Okay, is there anything to combine? No, so I'm done with that. Is the variable on one side of the equation? Yes, it is. It's on the left-hand side. Done. So now we just need to use inverse operations. I want to get x by itself. The inverse of minus 6 is plus 6. And you're left with 2x equals 18. Divide by 2. And you're left with x equals 9. Bam, boom. Alright, so now we're going to look at this question. Let's pick a good color. Let's go back to my green. And again, this question is still like solving for x. So again, we want to use don't call me impossible. So distributive property, combine like terms, move the variables to one side, and then isolate the variable. Okay. So can I distribute anything here? Yes, the 2. Boom. Boom. 2 times x is 2x. 2 times negative 7 is negative 14. equals -5 minus x. Boom. Finish distributing. Cool. Can I combine like terms? So on the left-hand side, there are no like terms. On the right-hand side, there are no like terms. So there's nothing to combine. All right. The next part is um, move the variables to one side. So I'm going to choose a different color. Are my x's on the same side? No, they're not. So I have to move either this x to this side or this x to the other side. And remember, you got to use, sorry, I forgot to check this off. You got to use inverse operations, right? So you could move the 2x over here by subtracting 2x on both sides. I'm going to do it the other way. So the opposite of minusing x is adding x. Remember, the coefficient in front of a variable is always 1. We just don't write it. Okay. And you're left with 2 plus 1 is 3x minus 14 equals -5. Okay. And we are almost done. Okay, we're almost done. So now I need to get x by itself, so I gotta get rid of this person. So what we're gonna do is we're going to add 14 to both sides. Okay. And we are left with, well, this adds to 0, so we're left with 3x equals -5 plus 14 is 9. Okay, we're almost there. I want to get x by itself, so I'm going to divide by 3 on both sides. This divides out to 1, so you're just left with x. 9 divided by 3 is 3. Boom. Done. Okay. Inverse operations. Donezo. Okay. This one I noticed that a lot of you had troubles with. And I don't think it's because you didn't know the math. I think you all know the math. I just think that you just didn't read carefully. So I'm going to highlight some things here. Okay. Ms. Fu wrote the following set of numbers on the board. A equals the square root of 20, B equals 2.5, and C equals the square root of 225. So this question has two parts. You have to explain why AB is irrational, but then explain why BC is rational. Okay? So there's two parts to this question. Two parts to this question. So I'm going to put a line down the middle. So we're going to do the first part. It's the first part. AB. So that's the square root of 20. And B is 2.5. Okay? Well, since square root of 20 is irrational, okay, and 2.5 is rational, a irrational plus a rational is irrational. Okay? And then let's do this color. BC. So B is 2.5 and C is 225. Square root of 225. Now a lot of you might say, "Oh, it's kind of the same question as this one." But you got to be careful. Do you know if 225 is a perfect square? Well, let's check. Well, the square root of 225 is 15. So, this becomes 15. Okay? If you add these two numbers, 15 plus 2, 17.5. Okay. 17.5. Now remember, it says explain your answer. So you have to write 17.5 is a decimal. That terminates. Therefore, what do we say? B plus C? B plus C is rational. Alright, so that's the end of that. Last question. The extra credit. So when we gave you the outline to the test, on the very bottom, I posted a picture of my cat, and I told you what my cat's name is. Most of you wrote Miss Fu. That is completely wrong. Miss Fu is another teacher in our school. So, it's not Miss Fu. The name of my cat is Riley. Okay? I hope this helps. Hopefully you have a little bit more insight why you did or did not get a question correct on the test. Um, and I'll see you next time. Have a great day.